In today's video, I want to talk about the reduce array method. Okay, so what is it and how can you use that? Now, I know it's a bit more confusing that I've seen a lot of people having trouble understanding what this function actually does. So let's get straight to it. Here I have a simple ledger that just says basically the amount that I've paid or received into my account. So here's just 15, 45, minus 30 and so on. And let's say I want to add them all up to see how much I have currently, right? To do so, I can use the reduce function on the ledger array. So I can say ledger.reduce, and this guy is a bit more complicated, but let's keep it simple. First, you have to give it a callback function. So this callback function takes in mainly two parameters. First one is the accumulator, and the second one is the current value. Okay, so I'm gonna just make it an arrow function, and I'm gonna leave it as is for now. And the second parameter is actually the initial value. Now, what's the initial value, you ask? Well, since we're trying to find the sum of it, what is a neutral value to our sum? Well, what is a value that you can keep on adding to a number and you're gonna get the same number? Well, that's simple. It's actually 0. So you can just use 0 in this case. It's gonna make sense in just a bit. Bear with me. All right, now think about reduce as a function that tries to reduce an array of whatever, not just numbers, to a single element. That can be anything really, an object, a number, a string, or even another array, no problem. But it's going to reduce it to just one element by iterating over the whole array. Now, this is not the same as a for each. We'll see in just a bit. So how does it do it? Well, basically it's a play between the accumulator and the current value. So the current value is just the currently iterated value. So it's going to go in this case 15, 45, minus 30 and so on. What's the accumulator? Well, the accumulator at first is going to be 0 because I gave it here 0, right, as the initial value. Then, well, the current value is going to be 15. So inside our first call of the function, the accumulator is 0 and the current value is 15. Simple enough. Now this function gets called for every single element in the array, right, until we have no elements left. So the second time this function is called, well, the current value is going to become, of course, the second element in the array, right? So it's going to be 45. I meant to type here, but it's going to be 45. But the question comes, what's this accumulator going to be? So first is we got the initial value, but then we don't have any more initial values. It's not going to be 0. So what it's actually going to be is the return statement of the previous function call. Okay, so in our case, this guy is going to be, let's say this equals to R1, just a number, random. And this R1, this is whatever returned, whatever this call with the first element returned. And this R1 is going to be passed as the accumulator for the next call. And then the same thing goes for the second call. It gets a return value. And that gets passed to the second call, or to the third call that I get here as the accumulator, and with the third element of the array, and so on and so forth. Okay, so this goes on and on and on and on, right? We get R1 here as the accumulator, then R2 as the accumulator. Where does it stop? Well, it stops at the last element, of course. So here we're gonna get, so this is 0, right? The accumulator for this call is going to be 0. Then you get R1, then you get R2. I'm gonna call this R3, R4, and R5, right? So I'm gonna just note the R5 here. I have R5 with minus 15. That also results into R6. What's R6 going to be? That's the actual return value of the reduce call. Okay, so this is going to be the result. Now, why is all that useful? Because we're just passing a variable over from the first call through 6 calls of the same functions. How's that useful? Well, if we treat this accumulator as, well, as the name suggests, as a sort of accumulator to put things into it, we can simply just add to the accumulator the current value. So you can say return accumulator plus current. What will that do? If we take a look at the results here, this is going to make R1, well, what's R1 gonna be? Well, the accumulator plus the current. So we're gonna get 15 here. Simple enough, so we get 15 here as well. All right. Then what's R2 going to be? Well, that's accumulator, which is 15 for our case, for the current value being 45, and that's going to be 60. And this 60 is going to be passed as the accumulator here. Here we get 30. I'm gonna also continue with the next calls. So after 30 is going to be passed here as the accumulator, and the argument or the current value is going to be also 30. So add those two up and you get 60. Next up, well, it's going to be 60 because that was the result of the last call, and then we get 15 here. So that gives us 75, right? And then the last one is R5, which we know now it's 75, and plus minus 15, that should be, well, 60. So as you'll notice, if you add all these numbers up, you're gonna also get the number 60. So in effect, what this reduce call did is simply actually add all the numbers together, and I can actually collect this result from here. I can say res equals that, and I can also console log this, and if I try to run this, you'll notice I get the expected result 60. If I change this value, for example, let's say 5, this is the initial value, what is going to happen? Well, you might actually notice I'm going to get 65. Why? Because this value changed to 5, and that propagated all throughout the calls, right? I got here, so from 15 we go up to 20, and then this 20 gets passed down here, and then you get 65, and so on and so forth. So the main takeaway from this reduce function is that it's going to reduce it down to just one single value, one unique value for that array. Okay? Now, how is that more useful than just iterating the array? Well, it's a bit shorter if you know the function and you know how to use it, and you also don't lose any sort of control over the for loop that you would have been using otherwise, right? If I have here, for example, if I want to sum every single number that's higher than 0, I can do that. I can say if current is higher than 0, then return this guy, and well, else if it's not higher than 0, then what do you think I should return here? Take a moment to think about it, since I would just want to take all the positive integrals here. So, all right, did you get it? I hope you did. The response is simple. The response is simply return the accumulator. Why? That's because if we instead don't add them together, our calls are going to become something. Let's take, for example, so for 15 we're still gonna add them, right? For 65 we're gonna add them, and here we have 65 as the accumulator, but we know this number is negative. So if this number is negative, instead of adding them together and get 35, we are going to simply return the accumulator, which is in fact 65. So in effect, we just skipped over the negative numbers. So we just added up only the positive ones. So I hope you now understand what the reduce function does. I know it's a little bit complicated, but once you use it once or twice, you're gonna get used to it. It's just basically a simple way to reduce a function to something that's useful, right? Thank you guys so much for watching. Leave questions in the comments down below if you have any, and see you next time. Take care.